Well, hello and welcome to our Vermont Hops Power Hour. My name is Deb Haliba and I work at the University of Vermont Extension Northwest Crops and Soils program, and I'm going to be helping out in the background, help guide us through this series. So before we get started, I wanted to give a few quick housekeeping notes, okay? First, we are really grateful to the Northeast SARE program that has provided funding for this project. We are recording the webinar today, and we will be posting the recording on our website and or YouTube channel, so we'll be providing that link to you following this webinar. And as a reminder, today's session is scheduled for 60 minutes, so in a minute I'll turn the mic over to Heather Darby and our featured speaker today, David Gent. But before I do, I want to just give a little overview of the agenda. So we'll have Heather and David speak, and then following their presentations, we're going to ask you to respond to 2 quick poll questions, and they'll just pop up on your screen. And then we'll transition the remainder of our time together over to a question and answer session. So we will hold our questions to the end, but if you want to pose a question at any time, you'll just type it into the question box. It will pop up. It's usually on the in your control panel on the right-hand side of your screen. If you're on a mobile device, you'll just click on the question mark, and that'll open that up for you. Okay. So with that, I'm going to turn the mic right over to Dr. Heather Darby.
Thanks, Deb, and welcome everyone. I'm really excited about our new webinar series called Hops Power Hour. And so we're going to be we will be holding a hops-related webinar once a month on the last Monday of every month, and there'll be a new topic, obviously, every month, hopefully to coincide with what's happening in the field. And so today with us we have David Gent from Oregon State University and the Agricultural Research system through the USDA, and he's going to be talking to us about downy mildew management. It's obviously a good time to be talking about that. I was out in the UVM hop yard last week, and hops had not emerged yet for us, but I know many folks around the region have hops starting to pop out of the ground. So time to be thinking about managing for downy mildew. And with that, I'll turn the webinar over to David. Thanks, David.
Great. Thanks, Heather, and thanks for the introduction. And yes, as Heather mentioned, my name's David Gent. I'm with ARS out of Corvallis, Oregon. I've been working, hops are mostly what I work on in my program. I've been doing this for this is my 13th field season with hops and working on disease issues. And so I'll be sharing a little bit on downy mildew management early in the spring. And so by a show of hands, who's seen downy mildew before? Okay, most of you. Okay, good. Okay, that's a joke. I can't see your hands. But this is, if you haven't seen downy mildew before, this is what the disease looks like early in the spring near training time. And so what we're looking at here, if you can see on my my cursor, these light yellow shoots that are stunted, and the nodes are very close together. This is a shoot infection from downy mildew. And this is, it's really critical to control the disease early in the year, because at training timing or shortly after training, infection can be quite impactful to yield. So we've seen this example. There's the shoots that are near the string are all infected, and so they can't be trained, they won't climb. And so this grower's going to lose whatever production would have been had on this string because of lack of healthy shoots to train, and that infection can occur later. So after training, after the expense has already been put in, that infection can occur then. So it's important to control the disease very early in the season. And so just the general outline for what I'll be presenting today is just a very short overview of the life cycle of the disease, and focus then on early season inoculum sources and when downy mildew can first be expected to appear. And of course, early season control measures, and then lastly, an update on fungicide resistance from some work we've done in the Pacific Northwest that has relevance for growers in other areas of the country as well. So this is just a cartoon diagram of the life cycle of downy mildew, and so there's 2 ways that the pathogen. It's a fungus-like organism, can survive. And so in the lower right, this is what can happen is there can be shoot infection in the previous year or infection at the base of a stem, and the pathogen actually will invade the root system. And then sometime during the autumn to early winter, you'll have the pathogen growing as what's called mycelia into these dormant buds, shown here at the bottom. And that can lead to death of the buds, but not of all the buds. But some of these infected buds in the spring, when they emerge, they'll emerge as those infected shoots, which are kind of colloquially called spikes, because they look like a spike on a wheat head. And that can kick off the disease cycle there as those spikes emerge. There's a second way the pathogen may overwinter, and there is a sexual stage. And so you have what's called an oospore. These are dormant spores that persist in the soil or in crop debris. And very little is known about this overwintering via these spores in the soil. But they are formed abundantly in diseased tissue. And this is what these oospores look like. This is some work that was just published just in the last month or so in plant pathology. And so if you take a diseased leaf, or especially a diseased cone, you'll find hundreds of thousands of these oospores, and they're found wherever you find downy mildew in the world, actually. And we looked at in oomycete pathogens, which is what the downy mildews belong to, you can have what's called homothallism or heterothallism. Homothallism means that an organism is self-fertile. It can form these oospores with one strain of the pathogen. And heterothallic, you can think of it as boy and girl. You need what's called an A1 and an A2 strain to have these. And so this is a really busy table. What we did is we took a number of different strains of the downy mildew organism, and these were generated from a single sporangium, the single spore. And then we crossed those in all possible combinations with themselves and other isolates. And the important thing to note here is in bold across the diagonal. This is the number of oospores that form when we cross these isolates with themselves. And so what this suggests is that we're getting, 400 to 4,000 of these oospores formed per leaf when the isolates are by themselves. So this suggests that the organism is homothallic, and so therefore we can expect to find oospores wherever we find the pathogen. I won't go into detail today, but we did follow up on this work, and we tried to induce infection with these oospores, and we weren't able to do it. So they are formed abundantly in diseased tissue, and presumably they're functional, and the pathogen probably wouldn't produce these and put the energy into it if they weren't functional, but we don't know what the triggers are to obtain oospore infection yet. So oospores are potentially present in the soil, so if the hop yard's removed and replanted, these could be present even if there's new disease-free plant material used. But this systemic infection through the buds in the root system, this is an important way of overwintering. This is probably the primary means the pathogen overwinters. And so what we're looking at in this image with the red arrow, this is one of these spikes emerging in early spring. And so you can see if you aren't really kind of tuned into what these look like, you might miss this. But it's pale yellow. These leaves are chlorotic or yellow colored. And if you turn these leaves over, on the underside of those, you'd see dark sporulation of the pathogen. And so this is what's kicking off the disease cycle in most yards. And so those spikes, they emerge with plant growth. And so in the Northwest, we did some work several years ago now where we looked at when they emerge, and you can predict the first emergence of those spikes based on degree days. And this is going to vary by variety and maybe by area of the country. But in what we see in Western Oregon is that near March 27th is about the average time we see these spikes emerging. And most of them emerge in a fairly short period of time near this degree day threshold that we've worked out. And one of the things that we see is that when you have a severe disease outbreak in 1 year, you tend to find those spikes emerging a little bit earlier the second year. So if you look in this bottom figure in the lower left, so this is a graph showing that on on the y-axis, this is how severe disease was in the previous year. So this is 100% of the plants would have had downy mildew, or 0%. And this is the degree days from the start date of when we see this first spike emerging. So what you generally see is that the more severe disease was last year, the earlier you tend to see spikes emerging the next season. But nonetheless, it's generally, as a rule of thumb, this is the emergence of downy mildew early in the year when you actually have disease in the yard as a function of plant growth. And so, and as I mentioned, you can predict that with degree days. You can also generally get a sense of this with scouting as well, and just looking at how large the plants are. So this is just this is useful though. This is data from this year in Oregon. And so looking at this degree day model, it was saying that the earliest we'd see downy mildew emerging this year was March 17th. We expect to find it in about 50% of the yards by March 26th, and in 95% of the yards by May 5th. So this is sort of the information you can get from this degree day model. And as I said earlier, the actual degree day threshold might vary somewhat by region, and the biofix or the start date might vary, but I think this pattern generally holds across regions. So this is kind of useful also because you can compare years, and we can see, like in Oregon, we're trailing 3 weeks behind where we were in 15 and 16, but we're pretty much spot on the 30-year normal. So the idea is that when you have these cold springs, this tends to delay the emergence of not only hops, but also of downy mildew as well. Okay, so one way we use this information, this is also some work from several years ago, but what we're looking at in the study was when to start the first fungicide applications of the year, and then how to time later sprays. And so this is a little bit busy, but what we're looking at here, these 5 lines that are color-coded, these are 5 different fungicide treatments we looked at. So the first one, this is our water sprays, so this is just the control. And the red is starting sprays after the spring pruning, and then applying those sprays when we have these predicted major infection events where we have rain plus a certain combination of temperature and humidity. Okay, so that's the red line here. And then this one below, this is the standard. This is just calendar-based sprays. Every 7 to 21 days after plants regrow from pruning all throughout the season. And then these bottom 2 lines that kind of run on top of each other, this is where we're putting the first spray of the year on based on this degree day threshold. So this tends to be before chemical pruning was done in Western Oregon. So this is so this red line is the one that says modeled. I believe this was 4 applications. These ones at the bottom, I believe this was 5 applications. So just 1 extra treatment. And you can see we get superior disease control from adding 1 early spray. And in fact, it's when you start the sprays is really quite important for how controllable disease is over the entire year. So this standard here was, I believe, 8 to 10 applications. So we're putting on half as many treatments with these lower 2, but they were started a little bit earlier and then timed according to weather. So I think the concept I'm trying to convey here is that you really want to be timely with the first application and have that coincide with the emergence of disease. And that's probably more important than how many sprays you make later in the season. Okay, and here's just a summary of that. So over these multiple years, we did this work. So it was 2005, 2008, and just focus on this bottom, this box highlighted in yellow. What we see here is that, so we were putting on 4 fungicide applications in 2006. The standard was 8, 6 versus 10 in 2007, 8 versus 4. So every year we're putting on about half as many sprays as a standard calendar-based program, but in every case we're getting similar to superior disease control when we start those treatments at the predicted emergence of downy mildew. Okay, so another, so that's really important for the chemical controls to mean timely with the first application. Another important early season control is this spring pruning. And so my understanding from Heather is that some growers have already been applying some pruning and the hops haven't emerged yet. And so this pruning can be done by mechanical means as shown in this picture here. And so what the grower is actually doing, this is just a modified deck mower with a hardened blade. And what they're doing is they're actually removing that new wood that was formed last year, and those surface crown buds formed of that new wood are the buds most likely to be infected and produce spikes. And so removing those gives disease control. And so this is just a close-up of this crown after it's been mechanically pruned. A fine point here is that if you're going to do this, there are some nuances to this. You can damage plants, and you also have to hill up soil each year. So you can't, they'll throw soil on these plants mid-year, and so they get that new wood forming because you can't mechanically prune more than maybe once or twice if you aren't hilling. But this is quite important. I mean, so that the Downy mildew pathogen has to have living tissue for its life cycle. And so if you take a yard on the left, one that hasn't been pruned, that pathogen is able to, it's active shortly after emergence, and you have many early season disease cycles. Whereas on the right, where they've mechanically pruned this, you've eliminated most of the substrate that the pathogen needs to live. And so you get quite a bit of disease suppression from this this pruning practice, particularly when it's applied over a large area like in the whole yard. And what we also see is that how well that pruning is done in spring is really, really important for later efficacy of disease control. And so on the top left here, this is actually a hop plant. It's been mechanically pruned, and the grower's taken a disc and they've kind of cut this down and cut these side shoots off. And so this is actually going to start regrowing. It will survive through that if it's done carefully. And this example is one where the grower's mechanically pruned, but they've left these side shoots here on the side. And then on the bottom, this is an example of a chemical pruning or chemical desiccation using herbicides. And so what we see on the bottom left here, this is a quite thorough kill where they've killed these entire stems. On the right, they've done this, but it hasn't been very thorough. They've left this green tissue. And so this is data where we looked in 110 hop yards in Oregon over a 6-year period. And again, we're looking at how severe is disease over the entire season that's expressed on this y-axis in relationship to how thoroughly was that pruning done in spring. Were the plants, where there's no green tissue, like that we call that excellent, or was there some green tissue left on every hill after the pruning practice? And you see this very pronounced stepwise increase in the amount of downy mildew over the entire season associated with how much green tissue the grower left after the pruning practice. We also had access to the grower spray records in this study as well. And when we looked at their spray records, what we actually find is these growers that have this excellent pruning, they tend to apply about 1 to 2 less fungicide applications per year than these growers have the poor pruning. So it's a double whammy. When you do your spring pruning, if it's not entirely thorough, you're getting poor disease control, and you tend to be spraying more than neighbors and other people that have more thorough pruning. So if it's done chemically, the pruning with herbicides, this can be quite tricky to actually do this thoroughly as well. So these are plants that was nugget, I believe, and the growers attempting to prune these chemically, and the plants were too large. And you see there's not very much. They've kind of desiccated this outer layer of the plant. There's still a lot of green tissue here. If anything, this might even make downy mildew worse because it breaks apical dominance and almost stimulates the pathogen to come out of the infected tissue more than not prune it at all. So this is suboptimal here. If it's going to be pruning is going to be done chemically, your goal is to kill all the stems, including the lower portions of the stems, which it's very difficult to do. But this would be an example of what that would look like. Okay, so that's just the section on the life cycle and early season chemical and cultural controls. I wanted to spend just the last few minutes of this update talking about some new work on resistance to the phosphonate compounds that we've confirmed in Oregon in 2016. And so the phosphonates, these are products that are phosphorus acid and phosphatidyluminium or alliate. So these phosphorus acid products, these are sometimes marketed as fungicides, and things like Fungicide would be one example of it, or Topaz would be another trade name. And then there's also a number of products that are sold as fertilizers, but they have phosphorus acid in in the product. And so these would often have names Phyte in there, like Nutrifite or something Phyte. And so this phosphorus acid has fungicidal activity and also stimulates plant defense responses. And in the western U.S., downy mildew control over the last 20 to 30 years, the backbone of that disease control has been based on this phosphonate chemistry because they're fairly effective and relatively inexpensive. So we did a fungicide trial in a commercial yard in 2016. And what we're looking at in this figure, so on the left-hand side here, all these yellow shoots, this is downy mildew. And you can see that these plants have a lot of downy mildew in the spring. And the ones on the right, this is a different fungicide treatment. And so this is a experimental product here. So it gave pretty good disease control. And the one on the left, this was weekly applications of fungicide applied at the highest label rate. And got no disease control essentially. And so this is just what that looks like. And so this is with something like 75 spikes per plant. These have something like 25 spikes per plant. So very dramatic differences in disease control. Again, these ones on the left were treated weekly with the highest labeled rate of fungicide. And so this is just a figure showing what that, I put in the number to what those pictures say. And so this is the number of those spikes per plant with the non-treated, with the fungicide, and then with this experimental fungicide. And so we can see we have essentially zero disease control with the fungicide as compared to the non-treated. And then we did this study at a second location, and this was much lower disease pressure, where it was maybe 3 spikes per plant in the non-treated instead of 75 in the last example. But what we see here is these two phosphorus acid products here. We have 2 now, one fungicide and this one called Prophyte. And those give about 50% disease control here. And then in green at the bottom, these are 2 other synthetic fungicides, again, and those are giving enhanced disease control as compared to the phosphorus acid compounds. And so we followed up on this, and we collected spikes from the field, and we brought them to the lab and cultured those, the pathogen off of those. And then we had a series of plants in the greenhouse. Some were treated with a quarter rate or a half rate or a full rate of fungicide, and et cetera. And then we inoculated those plants that were treated with these varying rates. And then we rated disease after a set amount of time to calculate what's called the ED50. So the effective dose of fungicide required to get 50% suppression of downy mildew. And so we did this for a number of isolates, and what we see from 2 farms that have had control failures with these phosphonate compounds, the median ED50 was about 2 times the maximum labeled rate. So what that means, you have to be putting on, instead of the 2 quart per acre rate, as according to the label, you have to put on nearly a 4 quart rate to get 50% suppression. Okay, and then of the isolates we assayed, the ED50s range from about 0.9 to about 60x the field label to get 50% suppression again. So we do have documented evidence of this population being quite tolerant to the phosphonates. And then this is just a figure showing the distribution of these ED50s, and so the median is about 2 times the maximum labeled rate, but we see this as a long tail, and there's some of these isolates that are very, very tolerant. I mean, some are tolerating more than 3 times the maximum labeled rate. So essentially, this population is you won't see any disease control from this level of resistance. And so what theoretically the rates could be increased and some suppression of disease could be achieved. However, what happens with this phosphonate chemistry is that there's actually a plant response as well. And so in certain varieties, they're sensitive to these compounds, and you can get phytotoxicity if you apply high rates. And so when we start putting on these really high rates of the phosphonate compounds, we're seeing this phytotoxicity. So even though theoretically a grower could just increase the rates, that they can't be done practically, because at the rates that are necessary to get suppression of downy mildew, you'll have injury to the plants. So essentially, these farms who have resistance, they have to stop using these compounds, as shown here on the right. So then one of the things we did was we looked at the relationship between the sensitivity of a number of isolates of downy mildew to this phosphonate compound Fungicide versus Alliet. So Alliet has a similar chemistry, but maybe perhaps slightly different in the way it works in terms of its direct effects on the pathogen. What we see here, there's a pretty linear relationship between the resistance to something like Fungicide and Alliet. So we expect that the growers that have control failures from Fungicide would also see diminished control from Alliet as well. And so this is a pretty major development because, as I mentioned, really the backbone of the growers' disease management program has been these phosphonate compounds. And so the good news is, at least in the Northwest, there's a number of other fungicides in different groups that can be used. The downside is these are all more expensive, and they themselves have modes of action that can be prone to resistance. And depending on what market growers growing for, they're trying to export, and there might be limitations on some of these fungicides in certain export markets. There's not enough different modes of action to put together a season-long program of highly efficacious fungicides when these phosphonates are not part of the mix. So this is a real concern to the growers here, and if there's germplasm in rootstock moving from the Northwest to other areas of the country, you have the potential for importing strains of the pathogen that have resistance to these phosphonates. What I haven't mentioned is that this Ridamil, this was a fungicide that was used in the 80s and 90s, and resistance developed to that quite quickly as well. And so if you're importing planting material from the Northwest, particularly from Oregon, you have the potential for importing not only isolates that have resistance to this group 33, the phosphonates, but also to Ridamil as well, and any other problems that might be found in the Northwest. So just to reemphasize the challenge this means for disease management, yes, there are fungicides that growers can use in place of these phosphonates, but these all have relatively short durations of control. From you're talking about no more than a week's worth of disease control in most cases. And so that means a lot of fungicide applications, and most of these are considerably more expensive. And so this adds a lot of cost and complications to disease management programs. I think on that bright note, that's all I have for this presentation. So with that, I will try answering questions that folks have.
Great, thank you, David. Before we turn it over to Q&A, we do have two quick polls, so they will just pop up on your screen. So here comes number one. So what you're going to do is just respond to this question: did you learn anything new today? So just click on one of those responses, and we will go through these quite quickly so that we'll have plenty of time for Q&A. Great. Excellent. Okay, here comes number two. Based on what you learned today, will you change or start a pest management practice? If you could just click on one of those responses, that would be wonderful. Great. Just a few more seconds here. Great. I'm just going to close that up. All right, so we have plenty of time for Q&A with Dr. Gent and Heather, and Scott Lewins is also on the line here. So as a reminder, to pose a question, you're just going to find the question pane, which should appear on your control panel. If for some reason it's closed, you can click on the little blue flower icon at the bottom of your screen to open up that control panel. And you just type it in, and I'll just go ahead and read those questions out loud, and we'll go through as many questions as you have, or as much time as we have time for, okay? So the first question I have here is, I had understood to mechanically crown just as the first bud surface. I'm seeing in your photos a much later pruning, quote unquote, pruning time after the plants are well leafed out. Would the Downy mildew spores have infected the soil by then?
Right, it's a good question. So on the The timing of pruning is a very important consideration. And I can't give you a good answer on what the optimum date is, but I can give you some principles. And those principles are, it's going to be variety dependent and location dependent in terms of climate, and then season dependent. And so you tend to have a colder year, you would probably want to be erring on the side of pruning a little bit earlier versus later, so that your plants have enough time to get the growth they need before bloom. And so that's everything you're doing with pruning timing is dictated based on what's optimum for setting training timing, which affects plant growth and therefore how big they are when they bloom. So that's the first principle. And then on the so that said, though, in general, later pruning suppresses downy mildew. And so within those constraints I mentioned, you want to try to be as late as possible without negatively affecting yield, which, what that date will be requires local experiments to determine that. Heather probably has some insights on what that might be for your environment. So in terms of the spores infesting the soil, so yes, those oospores are formed abundantly in diseased tissue, and but those are probably of secondary importance to the systemic infections that are in the plant. And so I think you could probably effectively ignore that. What is really important, though, is the thoroughness of pruning, as I mentioned. And when the pruning, there's a trade-off here. As long as when pruning is done later, you tend to have more suppression of downy mildew. However, that's predicated on having thorough pruning. It's harder to have a thorough pruning when you have more biomass you're trying to remove. So so it's not always done just at emergence. Maybe in the Northwest, at least, maybe in your environment, that's the right timing. But it's often done, in Western Oregon, the last week in March would typically be when mechanical pruning's done. So I hope that answers the question.
Great, thank you. And there's another related question about pruning crowning. We tried removing the newest wood last year and had an explosion of rhizomes further from the crown. How do we understand what to remove? We are not mechanized.
Yeah, so what's most important is probably that new wood that's kind of in the center of the hill is probably the most important to remove if you do some sort of pruning. But those side shoots are also important to remove. I mean, they're of secondary importance, but also important. So I think, so maybe the general answer is it's probably good to have the plants be somewhat distinct. Like if you have just a giant hedgerow of plants growing together, then that's going to be more difficult to prune. So having distinct plants where you're removing the top several inches of the new wood and then cutting down the sides or chemically removing the shoots on the side. I'm not sure I can answer any more specifically than that.
Okay, great. Moving to a different topic. How much is too much to build resistant to phosphonate products?
Mm-hmm. Yeah, so let's see. Maybe I could ask the question asker to clarify. Does that mean how much is like too much resistance in a given isolate, so you wouldn't see control, or how much use is too much?
Okay, we'll just wait a
couple
of seconds while he tunes in here. Why don't we? Oh, here we go. Can you use once a year to a few times?
I see. Okay. So based on the number of applications, yeah. So the label is the guide, and as I mentioned, there's some of these phosphonate compounds are ridge surface fungicides. Like fungicide would be an example, and in those cases, the label dictates what you should do. And I believe if you look at the label on those, it would say 4 applications a year, I believe. But check that and make sure I'm right. And some of the compounds, as I mentioned, are marketed as fertilizers, and so they don't have the restrictions of the label for a number of applications. However, I'd still defer to the label for the fungicide compounds like fungicide. And so the specific answer is no more than 4 times, and twice a year would be better. Ideally, there's enough diverse modes of action that a grower can put together a fungicide program that uses no mode of action more than twice, and that would be ideal.
Okay, and then just to clarify, so the resistance in the presentation that were used by farmers that had applied too much, or is it just something that the resistance is built up over time?
They were used too much.
Yeah.
The issue, it took a long time to get to these levels of resistance, and so Aliette was the first phosphonate that was registered in the late 80s, early 90s, and it gave quite good disease control. I mean, the growers could apply it, say, 4 times a year, and it gives symptom remission at times, where you'd have a spike and then it'd be treated, and then it would magically start to grow again. And so they were quite powerful. And then what happened over time was initially Aliette was labeled at a 2.5 pound per acre rate, and they'd selected for some insensitivity such that they had to, the Oregon growers had a special local needs label that allowed them to apply a 5 pound rate. And so then it took 5 pounds to get disease control. And then these products like these other phosphorus acid products came along that have a similar mode of action, and some growers are using those because they were cheap, like a few dollars an acre cheap, like $2 to $4 an acre. They're using those in essentially every spray for a couple decades. And so it was pretty gross overuse of the compounds. And even doing that, it took several decades of use to select for these levels of resistance. So I think in other areas of the country, if growers can learn the lesson of and use these sparingly, they'll continue to be useful tools.
Great, thank you. So in your degree day trial, what's the difference between model AI and model CU?
Right, I don't know, is my screen still showing to the group?
Yeah, it is. It would be helpful to go back.
Okay, let me go back there and find that. Oh, yes. Sorry, I didn't explain that very well. So this was, the CU is copper and AL is Aliette. And so what we're doing is we looked at what should the first fungicide of the year be. Should it be copper or should it be in Aliette? And so we didn't see a strong effect from using either one. So this is just 2007 in this slide. Let me go to the next one. And then this is the multiple year summary. And so, in most years, it didn't really make us have a strong effect. So either copper or Aliette as the first application of the year generally gave similar disease control.
Great. We have a couple of questions in the queue here about pruning or crowning with fire. So do you or Heather have any information to share on this technique? It would appear that this might be more effective or workable for small farms like ours.
Mm-hmm. So I'll give a brief answer, then I'll turn this over to Heather for her comments. So there are some growers, particularly in Washington State, that are organic growers that have used propane burners for pruning, and that can be done. And of course, if you have drip tubing, you'll need to remove that, of course. And but yes, it has been done, and I think it can be effective. Oftentimes the issue is cost. Propane is quite expensive, but so it's because of that, it tends to be limited to the organic growers. But with that, Heather, do you have any comments on or experiences with that?
We don't really have much personal experience with it, but this year we do have, I don't want to say, yeah, propane-based crowning treatment in our UVM trial, where we're, essentially waiting for the hops to emerge, which for us, they have not done that yet, and then we'll be burning them back. There are a few growers in the Northeast that are doing that right now. So we're trying to look at some particulars of that. So I don't have a whole lot to add either at this point, but it seems for those growers it's working. What we're really trying to figure out is the timing of it, and for us, you know, timing is everything because of our short season. So I'm not even sure if that will be a best option as far north as we are.
Mm-hmm.
And just a follow-up question, propane pruning won't reach the new wood, is that correct?
So I think what you'd be doing there is it'd be for killing the shoots that are already up. Let's see if I can find an example of this. When I say new wood, if you there is on the top of a hill, you know, you have this mass of, like shown on the lower right here, there's a mass of these shoots, and you get some of this wood development during the season from last year's shoots, and there's buds associated with that. So I don't think you're going to, I don't know if you'll actually kill the buds if they haven't broken yet, or if it's only the shoots that are up that you'd be killing. I don't think that you'd necessarily be killing those buds, surface crown buds. Maybe you would, but the ones that are, I would think would be just a centimeter below the surface would probably survive it.
Yeah, I would agree with David, just based on my experience using propane burning for weeding, you know, for weed control. You know, usually if it's hot enough, then you can, you know, desiccate some weeds, you know, maybe a centimeter below the ground, but probably not much deeper than that.
Okay, so moving on, a question about biologics. So do you know if the biologics have any efficacy, referring to double nickel, regalia, etc.?
Mm-hmm. Yeah, so I'm familiar with a few efficacy trials. I've conducted one myself, not with those products, but with 2 other biologicals, and they maybe Heather has some local knowledge of this too, but under high disease pressure, what you tend to see is that they aren't very efficacious, and so it's difficult. It's really difficult if you're trying to put together growing a susceptible variety in a downy mildew favorable environment using only biologicals. It's quite difficult. So there's, as a rule of thumb, the biologicals are less efficacious than the synthetic fungicides.
Yeah, I mean, this is Heather. We've trialed a number of biologicals, and we've compared them just to copper. And I would, you know, agree with what David said so far. We haven't really seen anything that can protect the plants, you know, to the extent that likely the synthetic fungicides would, and then also the copper as well. We have had some success if we have good control at the beginning of the season and not really high downy mildew pressure, rotating the copper with some of the other biologicals, and that seems to work okay. But as a sole, you know, treatment for downy mildew, we haven't found anything yet. And we do have some reports on our website. I'll put that up here on in the box that you could look at and see our results so far.
Great. Is there any truth to crowning 30 days before planned training?
The hard part, that's a rule of thumb I've heard mentioned by several growers, and the challenge here is the correct crowning time, whether you do it mechanically or chemically, depends on what the weather does after you crown. If you have the weather turns really warm and the plants grow quickly, I mean, maybe you could have waited a few more days. If it turns cold, probably you wanted to go earlier. So it's really hard to generalize that. We did a series of pruning timing studies, and there's a huge variation from yard to yard in what was optimum. And not only, one other thing that plays into this is vigor of the plant. And so if you have plants that are a little bit weakened from some other factor, maybe it's, I don't know, maybe they just don't have a lot of carbohydrate reserves, they're weak last year, or whatever the reason might be, those might take longer to respond to regrow. And so I've heard that number thrown out by some growers. Often what I've heard is 4 weeks is the number they use. But I think it's more nuanced than that. And this is not a very satisfactory answer, but really by experience, you'll know what works in your environment and with the vigor of your plants. And I think that's probably 30 days might be okay as initial place to start, but you probably want to fine tune it from that, and certainly variety dependent as well.
Great. Do you have to wait for good leaf surface to make your first applications of copper, etc.? Is it worth spraying the shoots?
Yeah, is it worth spraying the shoots? So let's see. I'm gonna scroll down here if folks can still see my screen.
They sure can.
I wonder if I can do this without confusing everyone. But we did a study. So I'm gonna go here to slide 42 and open this up. So we did a study a couple years ago, looking at the timing of the first application. So I showed that earlier slides on timing the first application based on degree days, and there was leaves out at that time. However, a fine point here, that was a very high disease pressure situation in nugget that had a lot of disease. So we did another study, and this is based on the first detection of spores in the air, and so we were detecting those with various spore traps, and then let's see, this is just a graph showing disease levels, and this red indicates when we're detecting spores in the air. And then this is the summary of all this work was effectively what it comes down to is you can apply disease at the first detection, you can apply your first fungicide at the initial detection of disease, which coincides with the first appearance of airborne spores. And if you apply your first fungicide when you only have shoots out there, no leaves, but there's no downy mildew present, that's an application's wasted. Now, on the other side, if you wait too long and you have disease out there, then that's suboptimal as well. And so the whole upshot of this summary of this study was over 6 years in 6 location years in commercial fields and 3 years in experimental plots, when we applied the first fungicide based on the first detection of disease, that was optimum. You got good disease control and didn't put on excessive sprays early in the spring.
Great. Let's see. Someone asked if you could show your fungicide slide again, the one with the resistance ratings.
Let's see. Number 27 here. Is that the right one?
Yeah, I believe that's the one.
Okay. Okay. So this is this is from the Pacific Northwest. If you Google Pacific Northwest Plant Disease Management Handbook, you'll pull up this very extensive website that has current information for a number of crops. And if you put in hops and go to the hops page, it'll have some information on each of the diseases on hops, information on cultural controls, biological, when there's information, and chemical controls. And the fungicides listed there, this is for the Northwest, but it's maintained up to date. And so I got this information from that PNW Plant Disease Management Handbook webpage.
And I'll try to get that link up for you all to post it in the chat pod here. Let's see. So what are the downsides to selecting bines to train early in the season? Ours appear to be ready to go.
Good question. So every variety has an optimum training date, which interacts with the year somewhat. And so what can happen if you train too early, let's say something like Centennial, for example, and if you get a lot of excessive growth and then the weather turns warm, you get some freakishly warm May, you can have plants blooming when they're 6 to 8 feet tall with something like Centennial. And then once they bloom, they're not going to grow anymore. And so this early bloom or split bloom reduces yield. So there's a optimum time. Like you can train too early and you'll get excessive vegetative growth. You run this risk of early bloom if the weather turns warmer. And then if you go too late, well, you're not going to have enough growth there, and then the plants, again, they'll be too small. They won't reach the top wire, and they're going to bloom too prematurely. And so every variety has an optimum. And so this, again, goes back to local experiments and local knowledge about what the optimum training date is. Just because you have early season growth doesn't mean you necessarily want to train it. It might actually in your environment and with certain varieties, but it doesn't necessarily mean that. So one last comment on that. So when a new variety is developed or released, or a grower has a new variety on their farm, what they often do is they sort out pruning dates and training dates, just experimentally. They'll take a row or a section of a row, and they'll prune them on one date, and then they'll come back and train later, and then they'll have another row or section they'll do a week later or 2 weeks later, and they do this over the course of several years, so they can they might have a general idea of what would be recommended or ideal, but they do this on their own to learn what's optimal on their farm. So that's the general recommendation I'd make to the folks on this call, is you really have to play with this a little bit in your own situation to dial that in.
Mm-hmm. And related to that, is training related to growing degree days?
It probably is. I'm not sure precisely how, though. I think in general, on a warm year, the growers, because of this early bloom issue, they do try to hold the growth back a little bit. And because, so you're working backwards from your goal. Your goal is that your plants will grow and reach the top wire, grow over the top wire, and produce long branches or side arms from the top of the plant as far down as possible just before you hit the critical day length that triggers bloom. And so they're working backwards from that goal. So, and so when you have a warm year, they would tend to be, they might prune a little bit later. They might, sometimes what some growers do, they might do some pruning, say mechanical pruning in the Northwest, and then if they have the regrowth is rapid, they might actually come back and chemically desiccate that growth just to hold it back until they get to the timing where they will avoid that early bloom issue I referred to, but still get the growth they need. So yes, so kind of, it's not quantitatively worked out, but there is some relationship to temperature and training date.
Okay, so do you have to pick up what you prune for the disease not to spread? So the prunings.
Good question. No, so you don't need to do that. So yes, even though there are those overwintering spores that you find in diseased tissue, you find those are probably far less importance than the disease that's systemically in the plant or airborne inoculum coming in from the neighboring yards. So no, it's the pathogen will effectively die when the host tissue dies, and those. So no, it's not important. I mean, in terms of at harvest time, and let's say you have a big pile of leaves and crop debris, it's probably worthwhile to compost that if possible before spreading it back on the field. There's not good data on that for downy mildew, but it probably has some effect. And for powdery mildew, we haven't talked about that today at all, and it's probably powdery mildew seems to be mostly a minor issue at present for most growers in the eastern U.S. But there is a stage of the powdery mildew pathogen that can persist in crop debris, and so for that reason, composting at the end of the year is probably good. But no, in the spring, you're okay to leave it in place.
Great, thank you. I'm just looking at the questions here. I think you've responded to all of the questions here. Any last questions from the crowd? Okay, I'm going to just turn it over to Scott Lewins with that. Thank you so much, Dr. Gent. We really appreciate
Yeah, absolutely.
your time. And then I'll just turn it over to Scott, and he's going to talk about what's coming next.
Thank you, Deb, and thank you, David. That was great. So, as Heather mentioned, we've got a number of experiments as a part of this project. The crowning experiment, we'll be looking at mechanical and the propane-based pruning. We're also planning on looking at the impact of natural enemies in our hop yards in this region, optimum nitrogen rates, and then also screening wild hop germplasm. In addition to the experimental component, we have a robust educational component that includes conferences as well as on-farm workshops and YouTube series that we've been doing in the past. And as part of this program, the two new things that we're trying out are these Hops Power Hours that you guys are participating in. The next Power Hour, May 22nd at noon. We'll be looking at fertility management and irrigation, and then continuing on the last Monday of every month through September. As Heather mentioned, we'll be looking at various topics that are seasonally appropriate. The other component is the Go Scout program, where we will send you email invitations to answer a handful of short questions every other week. Those questions, those prompts will involve questions about your fertility applications through the season, as well as pest management. So we'll be focusing on the three main pests in our region: potato leafhoppers, two-spotted spider mites, and hop aphids, as well as beneficials, as well as downy mildew. And so we'll be looking to you guys to share what you're seeing as you scout your yard. We'll also be asking about what actions you plan to take and if you need any additional information. And we can then compile those responses to help all of us learn more about pest pressure, management options through our region during the next couple of seasons. So I want to, really put a very big thank you out to all of you for participating, and look forward to learning from everybody who's participating in this program.
Great, thank you, Scott. Heather, any final words?
No, I think that's great, and we'd encourage people to participate in the Go Scout program. I think it'll be helpful for folks. We get a lot of emails and phone calls, asking about how to identify different disease and insect pests, and we want ultimately for everybody to learn how to do this on their own, and I think this is a great way to get started. So other than that, we'll see you soon.
Great. Thanks so much, all. Thanks for joining us. And Dr. Gent, thank you again for giving that great presentation today. We really appreciate it.
Absolutely. Thank you.
All right. Take care, everybody. See you next month.
Bye-bye.